All right, section 7.5 deals with basically three things we're going to talk about today. All right, and they're actually three things that we've talked about in the past. So it's nothing, well, the three words we're going to talk about are not new. So here's the first one. The first one is altitude. Do you remember what the altitude was? Let's grab this triangle right here. Let's make it a little bit bigger so we can draw all over it. Let's put that thing right there. Do you recall what the altitude is? You start at a vertex, and where do you go from there? Do you go to the other point? Do you go to the midpoint? Do you go, what do you do? You got it. Yeah, it's perpendicular, exactly right. So you start from this, from any point. I could have started down the bottom left or the bottom right, doesn't matter. I just decided to start up top here. So if I start up top here, I wanted to draw the altitude. Remember talking about if you're in an airplane, the pilot gets on there and says, we're flying an altitude 20,000 feet or whatever. Okay, where's he measuring from? If this is the plane right here, where is he measuring from? Is he measuring to where you're trying to go? Does he measure to some point behind them? Directly underneath of them, right? And what is directly underneath? That would be what? Perpendicular. All right? So the altitude is perpendicular. Now, look what that altitude does. Oh, you know what I did? Let's group that together and copy it. I meant to draw two triangles. Silly me. Let's just make this one. We'll copy and paste. Just make this one a little bit smaller. There we go. That's better. This is what we're talking about. So we're comparing two triangles to each other. But look what I drew here. Look at that red line right there. That's an altitude, isn't it? And what's this little red line down here? It's also an altitude, isn't it? All right, because it's perpendicular. And notice they both start at the same vertex. Everybody got it? So let's put some letters in here. Let's make let's make that altitude A. We'll make this altitude B. Then I'll call this side C. And I'll call this one D. Call this one E. Call this one F. All right? Now here's what you're doing. And you're going to do this basically 3 times. So once you get the hang of the first one, the other two are pretty much just like it. All right? So hopefully you'll understand what we're going to do. Here's what it says. It says that if the two triangles are similar, so if the triangles are similar, then all this stuff that I'm going to show you is true. All right? So I just put a dot, dot, dot. I'll put the stuff that's true down here. So watch what we're going to do. We're actually going to compare the altitudes to each other. So if I took the ratio of the altitudes to each other, how would I write this? If I made this altitude A and this altitude B, how would I write that if I wanted to show the ratio of the two altitudes? What would I write? A to B. That's right. A over B. Okay? So the ratio of the altitudes, okay, is going to be the same as the ratio of the corresponding sides. What in the world does that mean? It means the altitudes and the corresponding sides are in proportion. So if I compared A to B, what do you think that would equal? Let's start with C right here. What would I do there? C to D, exactly. It's real simple, okay? It looks pretty straightforward, don't you think? So if I compare A to B, that's going to equal C to D. Of course, they're going to put numbers in here, aren't they? All right, and maybe leave some variables, and you have to solve for the variable and all that kind of stuff. But this is the setup we're going to do. This is how we're going to set the stuff up. And we'll do an example right before we finish here. So if I compare A to B, that's going to equal C to D. What else do you think might be equal here? What other ratio? Yeah, E to F. It's pretty straightforward, isn't it? So if I compared A to B, now remember, if the triangles are similar to each other, so we have to know the triangles are similar to each other, and if they are, then I can compare the altitudes to each other, and that's going to equal the comparison, or the ratio, of the other corresponding sides. So look, this is the left side, this is the big left side, this is the little left side, so I compare them to each other. This is the big right side, this is the little right side, so I compare them to each other. This is the big altitude, that's the little altitude. I compare them to each other. Does that make any sense? Okay. You could also, if you wanted to, you could also compare this big side to this little side right here. What do we get? E, F, what? G, and H. So if you wanted to, you could throw in that as well. You could put G over H. So those are all the different comparisons that I can make. Now remember, I said we're going to do 3 of these, right? The first one is the altitude. Does that make sense? All right, so again, you realize we're going to put some numbers in here, right? And one of these will be an x. You know, you're trying to solve for it. So you put the numbers in. Now you're not going to use like all 4 of these at the same time. You're only going to use 2 of them, right? Depending on which altitude you know and which corresponding sides you know and all that kind of stuff. So you're only going to use 2 of them. You put the stuff in there that you know, and then you cross multiply, and then you're good to go. Make sense? Don't just set stuff equal to each other. I've been seeing that lately on some of the homeworks. Okay, and I think you're just doing it because you don't want to think and you just want to get stuff done, all right? Or you think you're getting stuff done, but you're really not. Think about, use your homeworks as good practice. Okay, that's why I give you the homework, is so that you understand how to do the problems. If you just write down a bunch of junk just to get a 5 on the homework or just to get a few points on the homework, that's not going to help you. The homework is there to help you. You're supposed to be trying to do these problems. If you're not trying to do the problems, the homework's a waste. And I don't want it to be a waste. All right, so the first thing was altitude. Now, the second thing is the angle bisector. Do you remember doing this a while back? We did altitudes and angle bisectors and all kinds of stuff like that. So now we're going to do an angle bisector. Let me go back up there and just grab my triangles. I'll copy those. Paste them right there. Perfect. The only thing is, I don't want that altitude in there because I'm not going to do an altitude this time. I'm going to do an angle bisector. And that should sound familiar to you. Okay. So what we're going to do is we're going to go up to one of these angles. Again, you could start at this angle down here. You could have been this one over here. I'm just trying to be consistent. Do it the same angle every time. What I'm going to do is I'm going to bisect this angle. Bisect the angle. So what I'm trying to do is I'm trying to find out where it looks about halfway. Everybody see that? I'm not going halfway to the other side of the triangle. That would be something else. Okay, this right here is what I'm trying to bisect. So that's what I'm looking. So I'm stretching this down. Look at the top of the angle again. That's pretty close to being bisected, don't you think? So if I bisected this angle, let's show it. So this angle and this angle should equal each other. Let's do the same exact thing on the other side. Johnny, you getting all this down? Might be a good idea to take some notes on this. So it would be helpful. So let's bisect this angle. So watch what I'm going to do. I'm taking this little angle at the top. I'm trying to split it in half. That looks pretty close, don't you think? And so those 2 angles would equal. So look, I got 2 angle bisectors. Let's use different letters this time instead of the A, B, C. Is that all right? Because the other class I use the same exact letters. It might be better if I just use different letters. Let's use, I don't know, P and Q. And then we'll call this R, S. And then we'll call this T and U. Is that all right? So let's set up our ratios now. Now again, this says if the triangles are similar to each other. So I've been told, or I've been given enough information to say that they're similar to each other. All right, so let's just pretend we know they're similar to each other. So if they are, we can set up a ratio. Josh, you getting all this down?
Yep.
Get your head up, please. So look at this. We're going to set up a ratio. So now we're going to take the ratio of the angle bisectors. Which ones are the angle bisectors here? P and Q. So we're going to set them. So we're going to compare them. So what other comparisons do you think we can make then? So if I go P to Q, what do you think I could do? Now I've already compared P to Q. Come on, watch what I did up here. Come on, follow along. You said T? Oh, I thought you said P. I'm sorry. Okay, so watch. We went A to B, right? And then we went this left side to the left side. Then we went the right side to the right side. So it's really the same exact comparisons, right? And it still wouldn't be T to S, though, would it? Right. It'd be R to S, and then be T to U. Why? Because R is on the left side, and S is on the left side. They're corresponding sides, aren't they? All right, so I'm going to compare R to S. What's another one? T to what? T to U. And let's call this one down the bottom W, and let's call this X right there. And then if you wanted to, you could also say W to X, couldn't you? It's pretty much like the one we did before with the altitude, isn't it? Pretty much the same, except this is not an altitude this time, it's an angle bisector. So we can do the same thing with an angle bisector as you can do with the altitude. Make sense? Yeah, that's not hard. And we got one more, and it's pretty much the same exact thing, except we're not doing, I'll tell you what, let's get rid of that. Let's grab this triangle and this triangle. There it is. All right. And what's the third thing? The third thing, remember before I went from here and I said we're not going to go to the midpoint, but what if we did go to the midpoint? What would that be called if I went from an angle or from a vertex to the midpoint of the opposite side? Anybody remember what that was called? To the midpoint, to the middle. In the middle of the road is a grassy, it's a grassy area. What do we call that thing? It's the median, right? It's the median. So if I take this from here, I'll tell you what, I'm gonna just put a little dot right where the midpoint is. I'm gonna do the same thing over here, just so I'm pretty accurate. All right. And let's make this. Now, what do we make? We made it red before, didn't we? That one that split it. Let's do the same color. So watch. If I went to there, to the midpoint, and then I went from that same vertex, right, to the midpoint of that side. Now, these two sides are obviously not equal to each other in length, are they? All right. But if they're part of similar triangles, and watch this. What do we call that thing? The median. Right. So if I draw the median of both of these triangles, what do you think is true? I don't know, let's try some other letters. What other letters can we use? Let's just go A, B, and C. It's a lot easier. So let's go, I'll just maybe mix it up a little bit. A, B, C, D, E, and F. Is that all right? So let's take a look at that. That's a weird looking C, isn't it? Let's try that again. No, that's okay. That's good enough. All right, so let's do some other comparisons. Let's compare the medians. So if these triangles are similar to each other, I'm going to compare the medians. What are the medians here? E to what? E to F. All right, following what I'm doing? We've done this twice already, so it should be easy. Then what are my other comparisons I can make? A to B, and what else? C to D, right? And if I knew the third side, we'll call this E and F, all right? Well, it's already used F, and I used an E too, didn't I? E, F, G, H. How about G and H? Yeah. All right, so if that whole entire thing was G, and if this whole entire thing was H, I could also compare G to H. We good with that? All right. Enough of that. Let's do an example so you can see how we're going to use this stuff. Here's one. Let's draw this triangle out. Looks like that. Kind of looks like that. And that. Now remember, the only way that this works is if the two triangles that we're given are similar to each other, okay? So they have to tell you that they're similar, or you have to be able to figure out if they're similar or not. And I'm going to shrink this down a little bit. Now, this triangle, they don't just have it sitting looking exactly like this one right next door to it, all right? They twist it and flip it and that kind of stuff. So let's try to make it look like what they do in the book. Here we go. So let's reflect it about like that. And then I think they twist it, don't they? Is that about right? Thought they did that. Hold on. Tell you what, let's get rid of this. I'd be easier. I tell you what, it's gonna be easier if I put the thing in here. And it says that this is an angle bisector, doesn't it? So watch what we're gonna do. Did I do this right? Okay, there we go. Watch. This is the angle bisector. So I'm just looking up at the top angle, just trying to bisect it as carefully as I can. So that and that are equal to each other. So now, watch, let's try this again. Let's group it, copy and paste it, make it a little bit smaller. And let's see what we can do to it. It looks like they rotate it around like that, but it also looks like they flip it. So let's try this one more time. Looks like they reflect it like that. There we go. That looks like it, doesn't it? Yep, that looks just like it does in the book. Pretty close to it anyway. So let's put some letters in here, and then we'll be able to figure out what we're trying to do here. This is A, C, and P, and B. And this one is D. And that's Q, and G. It's supposed to be a Q right there. And then F. Alright, and now they put some numbers in, so let's check out the numbers. They make this X. This one is 15. And this one is 8. And this one is 12. Alright. Took a lot longer just to draw the dumb thing than it does to actually figure it out. So let's do this. First of all, they tell us that these triangles are similar. Alright? So they tell you. It's right in the instructions. It says this triangle is similar to this triangle right here. So what we have to do, I tell you what, let's write out what triangles are similar, just so I can show you something. So ABC, it's a weird looking B, there we go. ABC is similar to FDG, right? So you can see right here that the A and the F are corresponding to each other, correct? The B and the D, right? This angle right here and this angle right here would equal each other, and then the C and the G would equal each other. So this third one and this third one would equal. Everybody see that? So sometimes that can be very, very important. So we know the triangles are similar. So what can we do? We can compare the angle bisectors to each other, right? Johnny, you getting all this? Come on now, please, make an effort. Try to just make an effort. You know, if you put something in your hand and you started writing down, okay, that's what I mean by making an effort. And you still haven't done that. I'm asking you very politely, just to get a pencil out, just write this down, or a pen. All right, let's just keep going. So I'm going to compare the angle bisectors to each other. So I'm going to go x to 8. Now watch, if I went x to 8, what am I going to do over here with my sides? Look, 15 is opposite C, isn't it? And the 12 is opposite G. So they do correspond to each other, don't they? Right? Because C and G go together, right? So 15 and 12 must go together. So the X, compare that to 8, and then take this 15, compare it to the 12. And that's all you do. That's basically what we learned today, right? Just to be able to do something like that. So you compare the angle bisectors, then you compare the corresponding sides. Yeah, absolutely. We're not done. Yeah, I'm just showing you how to set it up. All right, so now we just solve for x. So cross multiply, 12x equals 15 times 8. And 15 times 8 is 120, I believe. So 12x is 120. Divide both sides by 12, and you can do that in your head. What's that? X is 10. And that's all they want you to do right there. Okay, it's just solve for x. Does that make any sense? So again, you compare one of the things that they tell you. It could be an altitude, right? It could be a median, or it could be an angle bisector. So you compare them to each other first, and then you see which sides correspond to each other. How did I know that the 15 went with the 12? Well, this example was pretty easy because that was really your only other options, right? I mean, those are the only sides that could go together. But what if they gave you a whole bunch of sides? The 15 is opposite the C, and then the 12 is opposite the G. The C and the G are equal to each other, so the 15 and the 12 have to go together. Jan? All right. Yeah, there's one little thing we didn't get to yesterday, or not yesterday, but in the other class. But maybe I'll hit that tomorrow, right at the beginning of class. Okay, so remind me tomorrow. There's one little extra theorem that they throw in there, and I ran out of time in the other class, so I'll hit that, and we're about out of time now anyway, so we'll do that right at the beginning of class. But I am still going to give you that worksheet, so have that finished for tomorrow, and then that'll be it.